So we are going to look at proofs in a little bit more detail. So basically a proof is an argument which you brilliantly prove your point. Okay. So for example, we used to have this thing called morning detention. If you were tardy, you had morning detention. So an example, if you forget to set your alarm tonight, I can prove that you will have morning detention. Okay. Okay, so two-column proofs, they allow us to organize our thoughts in an efficient way, but also show that we have reasons for every claim we make. So everything you do, you have to justify it. Okay. So this is how a proof is set up. So you have two columns. You have the statement column on the left, the reason column on the right, and then the first thing is always kind of your easiest thing to fill in. This is your given statement and reason. This is just what the question gives you. It's the information that you're given. So don't ever miss that. So next is the body. So that's properties and theorems and definitions. That's that yellow sheet that we did. The yellow sheet that we did last Monday. And then lastly is what you're trying to prove. So that's just how a proof is set up. Okay. And we've done that. We've done miniature proofs, but we have not done a full proof just yet. Right. So some helpful hints as you're going through these. The first thing I do is I write down the information that's given and I write down what I'm trying to prove. That's going to help you get started. Make note of the conclusion. That's where you're going. Draw an illustration and mark all over it. So whatever the given information is, make a picture if they don't give you a picture. You know, if it says two congruent segments, make sure that you indicate those segments are congruent somehow. All right. So let's look at this. This is on your notes. I'm going to minimize this. So on this proof, we are given that segment JL is congruent to segment KM. JL congruent to KM. That's given. So your first statement says JL is congruent to KM and the reason is given. Right? Your first reason is always going to be given. Right? Your first statement is always going to be given. What are we trying to prove? We're trying to prove JK is congruent to LM. So let's go ahead and fill that in for F. That's what you're trying to prove. You know where you're starting and you know where you're trying to end up. All right, so just to show you, you're trying to prove that this segment JK is congruent to this segment LM. That's what you're trying to prove. Yep. Maybe. I just literally copied down what it said I'm trying to prove. Your last statement is what you're trying to prove, or your conclusion. So our given statement is JL is congruent to KM. Statement B says JL equals KM. So if you're going from congruent to equal, what property or definition is that? If something is equal, it's also congruent. What definition is that? This one comes up a lot. Definition of congruence, right? Yeah. Definition of congruence. So we're at B. Let's go to C. It says JK plus KL. JK. So JK plus KL equals the entire thing, which is JL. Right? So what would go in the missing spot here? JL. And then if you're using segment addition postulate for the other segment, KL plus LM equals what? KM. Right? So on step D, it says JK plus KL equals KL plus LM. If something is in another something's place, like if I leave for the day, who comes in? A sub. This is substitution property. So from step D to step E, we went JK plus KL equals KL plus LM. What did we subtract out? It tells us we're using the subtraction property. What did we subtract out? KL. We subtracted out KL. Okay. So now we can say JK equals LM. If we're going from segments are equal to segments are congruent, what property is that? Definition of congruence. Yes. Next example, it says given X is the midpoint of SY, X is here, and this is the segment SY, saying X is the midpoint of that side, of that left side. And then on the right side, we have Z is the midpoint of YF. Okay, so you know that XY equals YZ. So this is what it's saying. I would go ahead and mark my picture. It's giving you XY equals YZ. XY equals YZ. Those two segments are congruent. We're trying to prove VF is congruent to SX. That's what you're trying to prove. So, you don't know that yet? Let's try to prove it. So what is the reason for number one? What information is this? This is our given information. So the reason would just be given. That is the first thing you should always put. That's the first step in every proof. Your given statement. So if that's our given statement, let's see what number 2 has. It says SX, or segment SX, is congruent to the segment XY. Okay, so here we have X as the midpoint, right? We're given that. And the next step, or statement 2, says SX, this part right here, is the same as XY because that midpoint cuts that segment in half. Okay, that would actually be definition of a midpoint. Because X is the midpoint. And then on the other side, Z is the midpoint. So, knowing that information, scroll back up to the picture. We have, it's kind of hard to see. SX is congruent to XY, and then on the other side, YZ is congruent to ZF. So this is saying XY equals YZ. And that is just definition of congruence. For number 4, this is transitive property, and this is a little hard to see, but go back and refer to your yellow sheet with the definitions. Okay. So that was transitive property of congruence, and then step 5, or statement 5, that is what you're trying to prove. So do you see how those two are just switched around? SX is congruent to ZF, and then ZF is congruent to SX. That is the symmetric property. Remember, they were just flipped around. Okay, next proof. You're given that C is the midpoint of AE. So if we have AE, let's highlight that. C is the midpoint here. And then C is also the midpoint of DB, or BD. Okay. So C is the midpoint of both of those segments. Okay. So now that you know that, you also know that AE is congruent to BD. So those bigger segments, those are congruent. Okay. So this entire thing from A to E and from B to D, those segments are the same. We're trying to prove that AC equals CD. We're trying to prove this. Where is AC? AC is there. CD. And here we're trying to prove that those are congruent. So your first statement, what is that? Given. What is it? All that information. So C is the midpoint of AE, C is the midpoint of BD, and AE equals BD. All that information is your given information. And then fill in what you're trying to prove. You're trying to prove that AC is congruent to CD. Okay, that's already given to us. Sometimes it's not, and I like to fill it in if it's not. Okay. Okay. So we've got our given statement and reason. Go on to B. B says AC equals CE and BC equals CD. What allows us to say that? What allows us to say that? AC equals CE, so AC equals CE, and BC equals CD. What is point C? What is point C? It's the midpoint. So what allows us to say that those segments are congruent? Definition of a midpoint. Right? So if we go from step B to step C, what's going on? Okay, so look at your given information. The given information says AE is congruent to BD. So congruent and equal, definition of congruence. If it'll let me move. They have definition of congruent segments. Definition of congruent will work just fine. Okay. So segment addition postulate. If we take these, we're going to say the whole thing AE equals AC plus CE. Then the other segment, the whole thing, which is BD, equals BC plus CD. So from going from step D to step E, what did you take out? What did you do? We took out the AE and we took out the BD. So we substituted. And then this step is a little weird, but you substituted as well. If we have AC plus AC, that can be simplified to 2AC. If you have CD plus CD, that simplifies as 2CD. So 2AC equals 2CD. We can divide by something here. We can divide by 2. So we get AC equals CD. And then therefore we can say that AC is congruent to CD because of the definition of congruence. Okay, so we are given that DB bisects angle ADC, and we're trying to prove that angle 2 is congruent to angle 3. This is the angle bisector, DB, and it bisects the angle AD. So what's our first reason? Good. We'll never miss that. And then it gives you the reason for number 2. So what do you think the statement would be if the reason says definition of angle bisector? What does an angle bisector do? Cuts the angle in half. So what 2 angles would we have here? We have we have 1 and 2. If you wanted to name them, you could say ADB and BDC. But here, since they're labeled 1 and 2, you can just say angle 1 is congruent to angle 2. Then what allows us to say number 3? Angle 1 and angle 3 are vertical angles. What allows you to say that? Yep. Definition of vertical angles, or it may say vertical angle theorem here. Yep. Definition of vertical angles. So the next statement would just be angle 3 is congruent to angle 1 because vertical angles are congruent. So if we use the transitive property, angle 1 is congruent to angle 2, and then angle 3 is congruent to angle 1. You could also use substitution here. Do you see how we could take out the 1 right here? So angle 3 is congruent to angle 2. And then if you flip that around, that's what you're trying to prove. What property has them flipped around? Starts with an S. Symmetric property. One more example. So we have our given statements say angle 1 and angle 3 are complementary. Angle 2 and angle 3 are complementary. You're trying to prove angle 1 is congruent to angle 2. So what is reason A? Given. Good job. Okay. If 2 angles are complementary, they add up to 90. What is that definition? Definition of complementary angles. Yes, that's a little S right here. That's not an 8, that's an S. Okay. Here you're going to substitute in for the 90. So we're just going to set the measure of angle 1 plus the measure of angle 2 equal to the measure of angle 2 plus the measure of angle 3. That is substitution property. Complementary. You can also use subtraction property and subtract those out, but this is going to be reflexive property. Then we have substitution property and definition of congruent angles.